بسم الله الرحمن الرحيم. We'll start 2.4 continuity, and actually one-sided limit we did it in 2.2. Now we'll talk about continuity. So first we'll start with what is the meaning of continuity? The meaning of continuity, we say f is continuous at x equal a, f what? The limit of f of x as this goes to a equal f of a. That definition, if we look at it, it has three things. The limit exists, the function defined at a, and the third thing, these two quantities are equal. So we have actually three things to check. Okay. So this is the definition of the function if f is continuous at a number a or at a point a, if the limit equal f of a. Now let us deal with this problem. Just if you look at the graph, I know there is discontinuity at 1. There is discontinuity because I stopped, then I start something else. I have discontinuity here, and the same thing at 5. So we have three possible discontinuities. Okay. Here, why is discontinuous? Because f of 1 is not defined. So these conditions was not satisfied. For 3, very clear, the limit as this goes to 3 does not exist because left not equal to right. What about at 5? The limit exists. F of 5 defined, but they are not equal. They are not equal to each other. So the equality, what's missing is the equality, because the limit will be something here. This will be the limit, and this is f of 5, so they are not the same. Okay, clear? Okay, now let me do examples also. The same thing, but now for 4 examples. This one, very clear, f at 2 is undefined, is not defined. So f is discontinuous at x equal 2. Let me write something here. We say f is discontinuous at x equal 1. Why? Because f of 1 is not defined. We say f is discontinuous or not continuous at x equal 3 because the limit as this goes to 3 does not exist. Left not equal to right. F is discontinuous at x equal 5 because of what? The limit exists and f of 5 defined, but they are not equal to each other. Okay. Now let us do the same. F of 2 is not defined, so f is discontinuous at x equal 2. Now look at this one. F of at 0 is defined. I have no problem. But what will be the limit as this goes to 0 of f of x? The limit will be 1 over x squared, which is infinity. So the limit does not exist. So we say the limit as this goes to 0 for f of x does not exist. So the limit condition is not there. So the function is not discontinuous at x equal 0. Let me take this problem. The function is defined at 2. Yes. The limit, let me check. Limit x goes to 2 for the function. So we'll take this. That will be limit x minus 2, x plus 1. Yeah, minus 2. Yes, that's correct. The substitute, you get 3. What is f at 2? Is 1. So the limit, as this goes to 2, is not equal to f at 2. That means f is discontinuous at x equal to. Yeah. For the greatest integer, I notice if n is an integer. If n is an integer, is any integer. We know that the limit of f of x as this goes to n does not exist because left not equal to right. So that means f is discontinuous at any integer. And it's very clear from the graph. If you look at the graph, the greatest integer, that will be 0, open, 1, open, 2, and so on, and the other way. So for sure, at these integer values, we have discontinuity. Now, let us look at different ideas or different way of making questions. Find all values of a and b which will make f is continuous. So he's saying f is continuous, and he includes some values a and b, and he wants us to find what are these values. Okay. So first, you need to think about these functions. These functions are continuous everywhere. These are just polynomial, and we will discuss later that polynomials are always continuous. These are smooth functions. Okay, so I need to check what these points where I have a change from a function to a function. So we say I need to check f is continuous at x equal 1 and f is continuous at x equal 2. I cannot check. For sure it should be because he says f is continuous everywhere. What's the meaning if it's continuous at x equal 1? Means the limit as x goes to 1 equal f at 1. But when this limit exists, which means the limit from the right equals the limit from the left. So it's equal to the limit, so it's equal to f of 1. So I need actually this. This is what I need to check. Let us do it. Now, if I have limit, x goes to 1 from right for this function. From right means more than 1, so I am here. So that will be limit x goes to 1 from right of ax plus b. That will be a plus b. What is the limit? X goes to 1 from left. Left, man, less than 1, so I am here. So I'm there. So that will be limit x goes to 1 from left of x squared minus a. That will be 1 minus a. What is f at 1? Substitute the 1, that will be a plus b. So I need a plus b equal 1 minus a equal a plus b. That is redundant. I have nothing from here. So I can take it away. So it means what? 2a plus b equals 1. This is my first equation. Now for 2, let me do it quickly. That will be limit. It goes to 2 from left, and that should equal f at 2. Okay, from right, I am here. Let me do the calculation quickly. B minus 4. From left, I am there. So I have a plus 2b. Since x equal 2, and I have here b minus 4. Okay. So this equation is what? Is a, take b to the other side, a plus b equals to minus 4. So I have two equations, two unknowns. I need to solve them. Put them under each other. Very clear what I shall do. Just subtract. Subtract this from this. I'm getting a, b cancelled, b a equal 5. Plug it here. Here 5 plus b equal minus 4. So b equal minus 9. So this is the values where it will make the function continuous. Okay. Now, Also, we need to check the function. We need to define the function is continuous from the right or continuous from the left. Okay. What's the meaning of this? F is continuous from the right if the limit from the right, as it goes a from the right, is equal to f of a. From the left, if the limit from the left is equal to f of a. Why you need this? Actually, let me do it in the next one. So if you consider this function, f of x equals square root of x. Okay, and take integer n. Okay, let me take n. Yeah, just to see it, let n equal 3. What will be f at 3? Will be greatest integer of 3, which is 3. What is the limit as this goes to 3 from right for f of x? 3 from right. We know it before. That means if any substitute value more than 3, so the greatest integer will make it 3. However, if I do, it goes to 3 from left. It's less than 3. So the greatest integer make it what? 2. So the limit from right equal f of 3, but the limit from left not equal f of 3. So the limit as is to 3 from right equal f of 3. That means what? F is continuous from the right at x equals 3. We know that f is discontinuous, because the limit does not exist. F is discontinuous at x equals 3. I mean, in general, but from the right, it's continuous. From the left, it's not continuous. So this is not equal to f of 3. So f is not continuous from the left at x equals 3. By the way, if we take any n, any integer, the same result you will get. F of n will be n. This integer of n, which is n. N is just an integer. Limit from the right for n, for any n, that give me what? N. Limit from the left, less than n. So for sure it will be n minus 1. So this is equal. So it's for any n, the function is, this function is continuous from the right, not from the left. Okay. We say a function if it's continuous in an interval, if it's continuous at every number in the interval. However, if I have a closed interval, assume I have a and b, and I have a function defined just like this, from a to b. The function is defined from here to here, something like this. Who cares? This is my function. For values inside, I can't discuss the limit. You have problems. But what about a? At a, I cannot discuss the limit from left. And b, I cannot discuss the limit from right. So when we say a function is continuous in a closed interval, if it is continuous at every value inside, and for these endpoints, for a, I will consider only the limits from the continuity from the right. For b, I will consider the continuity from the left, because otherwise it's not defined. Let us take this function. What's the domain of this function? We know. Actually, I need to discuss this. This which is its domain, Between -1 and 1. So this is the domain of the function. Okay. I want to check in the continuous in every point in the interval. Okay. So we'll take a point C or A belongs to the open interval. Inside that or inside that interval. Not any of the endpoints. Where it means I have the x is a value between -1 and 1, so this is defined. So I can just substitute. What will be the limit? As this goes to a for f of x, it will be the limit. Since a is the value where this square root is defined, so just substitute 1 minus the square root 1 minus a square. What is f at a? It will be the same. Just substitute, nothing to worry about. So they are equal. So f is continuous at any x equal a, which is belongs to the interval, the open interval. Now, to check for -1, the endpoints for -1, I need to check it from the a. I check it only from the right. At x equal -1, check, is it continuous from right only, not from left, because the left is not defined. So I need limit x goes to -1 from right for f of x, that equal f of -1. Okay, limit this goes to -1 from right of f of x, that will be limit -1 from right for this function. -1 from right means what? Minus 0.999. Plug it here. Everything. Okay, that will be less than 1. So 1 minus something, so we can just substitute. It will be 1 minus the square root 1 minus -1 square. That will be 1, which is equal to f of -1. Now, at x equal 1, check continuity from left only. So that means in a check limit x goes to 1 from left, that should equal f of 1, and it's very clear. It's correct. So we say the function is continuous in this closed interval, -1 to 1. Okay. Find all numbers at which f is discontinuous, and at which, well, at which of these numbers f is continuous from right or from left or neither. Okay. These functions are smooth functions. Nothing to worry about. Just I need to check 0 and 1. Okay, so I need to check at x equal 0. I need to check at x equal 1. What will happen? Check the limit. Limit x goes to 0 from right will be what? From right means more than 0. So I'll take the e. That give me 1. What is the limit? As it goes to 0 from left. It means I'm take this x plus 2. I'm getting what? 2. So it's not continuous. F is not continuous at x equals 0. What is f at 0? F at 0, the 0 is defined here. It will be 1. So since limit x goes to 0 from right, so f of x equal f of 0, then f is continuous from right at x equals 0. But limit x goes to 0 from left is not equal f at 0. So this is 2 and this is 1. So f is not continuous from left at x equals 0. Now, at x equal 1, we'll do the same. Limit x goes to 1 from right for the function. From right, I am here. That will be what? Limit x goes to 1 from right of 2 minus x. That gives me 1. What is the limit? It goes to 1 from left. Left will be in the upper function. That will be e to the power x. That will be e to the power 1. Are they this? No. It means f is discontinuous, not continuous or discontinuous at x equal 1. Okay. What is f at 1? F at 1 is e. Substitute, the equality is here. So f of 1 equal e to the power 1, which is e. So it means f is continuous from left, because the left This is E, which is similar to this. Since limit x goes to 1 from left of f of x equal f of 1. But f is not continuous from right. Very clear, huh? I will leave it for you. Yeah, so this is E and this, so this is 1 and this is E. Okay, now let me do all the exam problems related to this definition. If we will G are continuous, so that G of 2 equal 4 and this limit equal 20. Actually, it's related to something later, but we can do it. Because we say if f or g are continuous, then 3 times the function is continuous. All of this is continuous. So it means this limit is just substituting. So limit x goes to 2 of 3f of x minus 2f of x g of x. I can distribute the limit. Actually, we'll do it later, but no problem. This is also constant. I can take it out. Minus 2 limit x goes to 2 f of x. Product also, I can deal with the product. Actually, we'll deal with that later, but it's okay. We can right now. So now the function f is continuous. So that will be 3 f of 2 minus 2. This is the function continuous. So I thought that will be f of 2 times g of 2. And that should equal what? He said it's equal to 20. Okay, now I'm looking for f of 2. G of 2, he guessed it's 4. So I have 3 f of 2 minus 8 f of 2. That will be equal to 20. So I have minus 5 f of 2 is equal to 20. That means f of 2 equals minus 4. That's it. Why I can't distribute the limit? Because it's continuous. This is continuous, and he wants f at 1. Actually, he wants a and b. And then you can find anything you want. Okay. So I need to check. This is continuous functions. These are smooth functions, no problem. So I need to check 0 and 2. Both should, the function should be continuous at these two values, 0 and 2. So for x equals 0, I have limit x goes to 0 from right. I will have two equations, two unknowns. Huh? And I just solve them. That will be f of 0. From right, let me do it quickly. From right, I'm here. Substitute the 0, you get minus b. Okay. From left, I will be here. Substitute the 0, you get 2b. F of 0 will not make a difference. That will be, no, sorry. Yeah, from right, that will be 0. I have 3a minus b. And from left, x will be 0. I have 2b. F of 0 will not make a difference because f of 0 will be 3a minus b, just redundant. So that will give us nothing. So from here, I'm getting what? 3a equals 3b or a equal b. Nice. For x equal to, what will happen? I need to do the same. Limit x goes to 2 from right. Limit x goes to 2 from left equals f at 2. From right, I am here. That will be what? 1. Yeah, 3 times 2 minus 5, that is 1. From left, I'm there. That will be 4 plus 3a minus b. F of 2 just will be a redundant. Yeah, no need to do something. So I have 3a minus b equals 2 minus 3. I didn't know that a equal b, so I take care of. So I have 3a minus a equal minus 3. That means 2a equal minus 3. That means a equal minus 3 over 2 and b also minus 3 over 2. Okay, so my function is what? Minus 3 over 2x minus 3 if x less than or equal to 0. Actually, I care about this one since the 1 is here. Huh? I have here x squared. Yeah, 3 times minus 3 over 2. That is minus 9 over 2. Yeah, that will be minus 9 over 2 minus b plus 3 over 2. if x between 0 and 2, 3x minus 5, if x greater than 2. Okay, this is what? This is minus 6, huh? Minus 9 over 2 plus 3 over 2, minus 6 over 2, so it's minus 3. Okay, now to check f at 1. If at 1 it will be here, just substitute here. You have 1 minus 3, which is minus 2. That will be my answer. If it is continuous, the same idea, continuous everywhere, then a minus b is what? Just I need to find a and b, the same idea. And I think we'll do a lot of problems. This question is usually repeated many times. Yeah. The same thing, though. I'm doing the same thing again and again. Okay. Let me do these problems quickly. Okay. So this is smooth function. This is smooth function. This is, I have a problem at x equal 1. But the function is defined as x greater than 1. So you have no problems. Okay. So I need to check now the 0 and the 1. At x equals 0, I have the limit. X goes to 0 from right. Equal the limit. X goes to 0 from left. Equal f at 0. Yeah, let me do the calculation quickly. From right, I am here. Substitute, you have b. From left, I am there. You have what? Substitute, you have minus 2. F at 0 will not make a difference. So b equals minus 2. Now, for x equal 1, you need to be careful here. Limit, x goes to 0, 1 from right. Should be equal limit, x goes to 1 from left. And it's equal f at 1. Okay. Now to do this, you need to do some calculation. Why? Because it's a limit. It goes to 1 from right. What is the function? X squared minus 1 over x minus 1. So we need to factor. This is cancelled, so we are getting 2. So this is 2. From left, I am there. Substitute, you get what? A plus b. F of 1 will not make a difference. F of 1 will be a plus b. Okay, so I have b equal minus 2. Substituted there, so I have 2 equal a minus 2, so a equal 4. What he want? He want a minus b. I have this, they have this, so that will be 4 minus minus 2, that would be 6, which is the answer. Continuous and find a plus b. Yeah, we did this. This is our smooth functions, nothing to worry about. So I have 2 and 3. I have limit for x equal 2. Limit x goes to 2 from right. Should equal limit x goes to 2 from left. Same idea. I'm just repeating myself. From right, I am here. Substitute. I have 4a minus 2b plus 3. From left, I am there. That will be 4. So what is the equation? 4a minus 2b equals 1. This is the first equation. Second equation, 3. Limit x goes to 3 from right. Should be equal limit x goes to 3 from left. Equal f of 3. F of 3 just redundant. 3 plus, I have what? 6 minus a plus b. 3 minus, I am there. That will be 9a minus 3b plus 3. Yeah, let us arrange it. I have 10a minus 4b. Yeah, it could be minus 3 equals, well, equals 3. Okay. So this one, yeah, so I have these two equations. I need to solve them. I have 4a minus 2b equals 1 and 10a minus 4b equals 3. You know what? I can multiply this is by 2 to get what? 8a minus 4b equals 2. And I just subtract. 10a minus 4b equals 3. If we subtract this, 8a minus 10a, that will be minus 2a. This is cancelled, equal minus 1, so a equal half. Plug it in one of the equation, like in this one. So we have 2 minus 2b equal 1. So we have minus 2b equal minus 1. So b equal half. A equal half, b equal half. What he want? He want a plus b, which is half, which is 1. So the answer is 1. Yeah. As I said, it's the same thing. Sometimes he asks about f of 2. I think we did this. Is it the same problem? No, he asked about f of 1 here. Yeah. He asked about something. So actually, he is concerned about this since 2 is here. Okay. Let's do the calculation. At x equal 1, I have the limit equal the limit from the left equal f at 1. Let me do it quickly. 1 from the right, I am here. That will be a minus b plus 3. From the left, I am there. That will be 3. So I have a is equal to b. Okay. X equals 3. F as 3. From the right, I am here. That will be what? 6 minus a plus b. And from the left, I have what? 9a minus 3b plus 3. Yeah. Yeah, I put x equals 3. So that give me what? 10a. Yeah, it's similar to the previous minus 4b equals 3. I have here the difference. I have a equal b. Almost the same except the first one. Okay. I have a equal b. So that give me 10a minus 4a equals 3. So 6a equals 3. So a equal 1 half. Oh, same thing. Yeah. So what will be b? Also b equal 1 half. Okay, so I plug it. I need this only. No need to write the function again. So I have at x equal f of 2. I have a is half and b is half. That will be half 2 square minus half times 2 plus 3. I took x since 2 is here, between this interval. So that will be 2 minus 1 plus 3, 5 minus 1, which is 4. So that will be minus. If the function is continuous, then what is a minus 2b? Who cares? Okay, now, okay, notice I have only at 1. But this is equality, this is greater, this is less, So now the f of a or f of 1 will make a difference. I consider only about 1, So I have limit, x goes to 1 from right, equal limit, x goes to 1 from left, equal f of 1. So I have two different equations. Okay. Before, no, I have only the same equation. Yeah, because f of 1 will be a minus b plus 3, which is the same equation. Now, f of 1 will make a difference. 1 from right, I am here. That will be 3 minus a. 1 from left, I am there. That will be 1 minus 2b. F of 1, a plus b. So I have three different equations. I have this is the first equation. I have this is the second equation. You can arrange it the way you like. Okay. So the first equation, it will be what? Take 2b to this side. So I have 2b minus a. Or take the a in the other side. So I have a minus 2b. Usually I like that to be positive. And take the one to this side equals 2. This equation will be what? A plus 3b equals 1. So I have these two equations, put them under each other, as usual. Subtract. This is 0. I have minus 5b equals to what? 1. So b equals minus 1 over 5. What will be a? Plug it here. So I have a is what? This is minus 3 over 5. Take it to the other side. That will be 8 over 5. Okay. What they want? they want A minus 2B. And that will be 8 over 5 minus 2 times minus 1 over 5. That will be 8 over 5 plus 2 over 5, 10 over 5, which is 2. Done. Calculation, yeah. Now, this is, is there a problem here? No, because x is equal 1 is not defined. Okay, so we have no problem. So now I check 0, I check 1. So what is the limit? X goes to 0 from right, should equal limit, x goes to 0 from left, equal f at 0. And that will be redundant because 0 and right is the same. Yeah, just to show it, as x goes to 0 from right, this is calculation, limit, x goes to 0 from right to this one. You need to do the limit, you need to rationalize. You'll get what? Limit 4 minus 3x minus 1 over x minus 1. Okay, that will be what? 3 minus 3x. Or 3, 1 minus 2, minus 6. This is cancelled, you have a minus sign. So that give me minus 3 over what? 3. That give me minus 1. That give me minus 1. Oh. No, sorry. What I'm doing is for x equal goes to 1. This is not correct. Actually, I'm doing it for x goes to 1, not 0. 0 just substitute. 0 have no problem. The problem is about x equal 1. I need to do the limit. So 0 just substitute. You get what? 4, 2 minus 1 over minus 1, which is minus 1. So that will be minus 1. Left of 0, it will be here. That will be A. F of 0, f of 0, it will be the same thing, minus 1. So this is redundant. Nothing. This is the same as this. Not like in this case. It will make a difference since x equal 1 is defined alone. So I have a equal minus 1. Now for 1, I need to do what I did before. Actually, I can leave it. Now this is the limit. X goes to 1 from right. Well, limit x goes to 1 from left. Equal f at 1. From right, it will be here. Just easy one. 1 plus b. From left, it's just a calculation. So this is from left because I need to rationalize. Because it will be 0 over 0 if we substitute. If we substitute, you have 4 minus 3, which is 1 minus 1, 0 over 0. So I need to rationalize what I did. Yeah. But I was thinking it's 1 and I was doing it for 0. Okay. Limit x goes to 1. That will be 4 minus 3x minus 1, x minus 1 plus 1. This is what? This is 3 minus 3x, which is 3, 1 minus x. So this is cancelled with this. I need a minus sign. So it's minus 3. For 1, it will be 4 minus 3. That will be 2. Yeah. For 1, it will be what? 4 minus 3. 1 plus 1. Yes, 2. Minus 3 over 2. So I have here minus 3 over 2. And this is f of 1. It will be the same thing, 1 plus b. So it's redundant because this is the same as this. So what is b? B equal minus 5 over 2. Take one to the other side. You need what? A plus b. That will be minus 1 minus 5 over 2, which is minus 7 over 2. Okay. Same idea. Is continuous, and f of 2 equals 3, then 2a plus b. Okay, he gave me another information. F of 2 equals 3. That help. Now, what I have, only one, is there is a change of the function. This function is defined since x is positive, and this is just a smooth function. Okay. So, this is, continuous everywhere. So I need to check at x equal 1, What is the limit? 1 from right, 1 from left, equal f at 1. From right, I'm here, just substitute, you have a plus b. From left, I am there, then 1, which is 0. And f1 equals 0, actually. So I have a equal minus b. I have only one equation. From where I get the second equation? I'm getting it from here. F of 2 means I substitute here. I have 4a plus b equals 3. So I plug a equal minus b, so it means minus 4b plus b equals 3. So I have what? Minus 3b equals 3. So b equal minus 1. So a will be minus b, which is 1. What I need? 2a plus b, which is 2 minus 1, which is 1. So that will be my answer. If it is continuous everywhere, what will happen? Yeah, the same thing. What is a and b? The same idea. These are always continuous functions. You have no problem. Just you need to check when I change the function. X equals 0, x equals 3. I need the limit. Yeah, the same idea is repeated, but for different functions. Sometimes they do a trick there or there, but it's okay. Positive, I am here. Substitute, you have b. Negative, I am there. But the 0, you have what? Cosine 0 is 1, so it will be a plus 2b. F of 0 will not make a difference. Huh? So you have what? A equal minus b. Now, at x equal 3, we'll do the same. F at 3, positive. I'm here, substitute 3 minus 7, that is minus 4. Negative, I am there. I have b minus 3a. Okay, I have a equal minus b. So I have minus 4 equal b plus 3b. Since a equal minus b, so b equal minus 1 and a equal 1. Did we did a mistake? He said minus 2 and 2. Wait a minute. Yeah. 0 from right, 0 from right. I am here. That will be b. Okay. 0 from left, I am there. Cosine 0 is 1. So I have a plus 2b. A plus 2b, that means a equal minus b. Okay. Now do this at x equals 3. From the right, I am here. 3 minus 7, this is minus 4. Now, at x equal 3, sorry. Calculation mistake. Okay. At x equals 3, that is b plus 3a. Yeah, now that will make a difference. Okay. Now plug this there. 3 is a positive, so it will be b plus 3a. That give me what? Plug a equal minus b here. That means minus 4 equal b minus 3b, which is minus 2b. So b equal 2. So a equal minus 2. So that will be the answer. Actually, from this, I can guess the answer. A equal minus one is the negative of the other. This is cannot, this is cannot, this is cannot, this is cannot. So this is the only solution. That's okay. Let's continue at x equal 1, x equal 2, then find a and b. That's it. 1 means limit. Be careful for calculation. From right, I am here. It will be 1 minus a. From left, I am there. So it will be a minus 1. And that should be equal f of 1, f of 1 just a redundant, which is 1 minus a. So I have what here? That will be 2a equal 2. So a equal 1. Now for 2, have limit. Same thing. 2, I am here. That will be b minus 4. From left, I am there. That will be 2 minus a, 2, huh? Yeah. F of 2 is just redundant. A equal 1. So I have b minus 4 equal 1. So b equal 5. B equal 5, a equal 1. So it is the point 1 and 5. Yeah. Yeah, I'm repeating myself, huh? The same idea again and again. Yeah. Okay. Let me do them quickly. He put only one variable, one value to find, and he put it only at 2. So I have at 2. My concern only at x equal to. So I have limit, x goes to 2 from right, should be equal limit, x goes to 2 from left, equals f at 2. That will not make a difference. From right, I'm here, that will be 8 minus 2c. From left, I am there, that will be 4c plus 4. So it will be that. That will be 6c here and 4 there. So c equal 4 over 6, which is 2 over 3. That will be the answer. Continuous, x equal 2. You want b minus a. I have only one equation. X equal 2. I have the limit. Let's go so from 2 from right equal limit is to 2 from left equal f at 2. Yeah, from right, I am here. That will be what? 4b plus a minus 3. And from left, I am here. That will be what? 4a plus b. F of 2 is just redundant. Okay. So what I have now? Take everything to this side. So I have 3b minus 3a equals 3. Divide by 3. So I have b minus a equal 1. I don't know what is a and b, but I know b minus a, which is 1. Since I have two equations, I need two equations to find a and b, but he gave me one equation. Since he asked about something I will get. If it's continuous everywhere, then what is a plus b? Yeah, look at this. I have no problem. And this one also have no problem since I don't have the equality. Equality I have it here, which is easy. So I check x equal minus 2 from right should equal from left should equal f at minus 2 from right. Minus 2 from right. I am here. Just substitute. You have minus 2a plus b. From left, yeah, I need to do this, which is not difficult. X minus 2, x plus 2, over x plus 2. This is cancelled, so I'm getting what? Minus 4. So this is equal to minus 4. So this is my first equation. This will be redundant. It will be minus 2a plus b. Now for x equal 2, check the limit. 2 from right, 2 from left, f at 2. 2 from right, I need to do this limit, which is x minus 2, x plus 2. Yeah, very clear. The answer is 4. So that will be 4. 2 from left, I will substitute here. That will be 2a plus b. So I have two equations, two unknowns. Just solve them. Minus 2a plus b equal minus 4. And 2a plus b equal to 4. Add them. You have 2b equals 0. So b equals 0. Plug it here. So 2a equal 4. So a equal 2. What he want? He want a plus b, which is 2 plus 0, which is 2. So that will be the answer. Let f of x equal this. What is this? This is, by the way, it's a way of writing it. Yeah, this is, by the way, this question is from the book. Similar to one in the book, where I need first to take care of this. You know that absolute value x less than 1 means what? X between minus 1 and 1. because I need to find A and B. So I need two equations, okay? So I have actually minus 1 and 1, not only 1, huh? And this one is what? X less than minus 1 or x greater than 1. So this function is what? If x is less than minus 1, so I will be in this one, so this is bx. If x, by the way, the equality is here, so this is with the equality. If x is between minus 1 and 1, I will be in this one, so I have a plus tan by x over 4. If x is greater than or equal to 1, I will be in this one, which is this function bx. Now, if I write it in this way, now it's very clear to me. I need to check minus 1, I need to check 1. So for x equal minus 1, limit minus 1 from right. Now I have right to left for minus 1 equal f of minus 1. Yeah, right, I'm here. Just substitute. You have a plus tan minus pi over 4, which is minus 1. From left, I will be there. That will be minus b. So I have the equation a plus b equals to 1. That's my first equation. Now for x equal 1, I do the same. F of 1. From right, I am here. That will be b. From left, I am there. That will be a plus 1. Since tan pi over 4, it's only 1. In this case, it's minus 1. Okay. So I have a minus b equals minus 1. I took b to this side and take 1 to the other side. So I have a plus b equal 1, a minus b equal minus 1. Add them. I'm getting 2a equals 0. So a equal 0. Plug it here. That gives me b equal what? What he want? A squared plus b squared, which is 0 plus 1. That would be 1. So that would be the answer. Okay. He gave me only one value, a missing. Oops. I have only a missing. Okay, so I need the 1. So I have x equal 1. Limit x goes to 1 from right. Equal limit x goes to 1 from left. Equal f at 1. From right, I'm here. That will be tan inverse 1 minus 1. That will be 0 plus 2. And from left, I plug it here at 1. That will be e to the power 0, which is 1 plus 3. So a equal minus 1. What he want? He want a squared plus a. That will be minus 1 squared minus 1, which is 1 minus 1, which is 0. Not difficult. The same thing. And he want a. We get a here. A equal minus 1. The same question, huh? Because it was in the book. Yeah. If this function is continuous at x equals c, he wants c. C is the one here. No problem. We'll do the same thing. Limit x goes to c from right. X goes to c from left. Equal f of c. From right, I am here more than c. So I have c. Oops. So I have c. And from left, I am less than c. I have 1 minus c squared. Okay. So I'm getting what? C squared plus c minus 1 equals 0. How to solve this equation? Yeah. C squared. Did I do a mistake? No, this is c. And as this goes to c from left, have 1 minus c squared. So you have c squared plus c minus 1 equals 0. This is quadratic equation. So I need to solve it. Let's see what will happen. Okay. Now I'm looking for this. 2c plus 1 square. I'm not looking for c. So if you open this, this is the trick. If you open this, this is 4c square plus 4c plus 1. Okay, if you notice, 2c plus 1 square, there is the catch, plus 1. And this one is what? Notice here that c square plus c is equal to 1. Huh? So this one is 4c square plus c plus 1. And this is a no. This is 1 without finding c. So this will be 4 times 1 plus 1, which is 5. So 2c plus 1 square will be 5. No need to find c. Okay. If it's continuous, so I have at x equal 2, limit x goes to 2 from right, equal limit x goes to 2 from left, equal f at 2. From right will be here, that will be 4a. From left, that will be there, it will be 8. So a equal 2. Easy one. I think you have 2 to go. 0. So it means the limit as it goes to 0 from right equal the limit as it goes to 0 from left equal f at 0. So from right, I'm here, that will be a minus 2. Only a, huh? Since x equals 0, so it will be a. What about this? Oh, I need to do a limit. Limit x goes to 0 from left, 4 sine x over x. I know this limit. This is 1, so I have 4. So a equal 4.